Today we're looking at writing the equation of a line using its gradient and its y-intercept. This is the form of the line y equals mx plus b, where m is the gradient and the y-intercept is b. Also in the past it used to be called y equals mx plus c. So b is a constant, which is the y-intercept. So it's when x is equal to 0, y-intercept. Okay, so what we're going to do is we're going to use information from the graph like we've been doing up to date. If we have 2 points, we're going to work out the rise and the run. We're going to work out the gradient using the formula m equals rise on run. And we're going to look at the sign, put in the sign. Then we're going to read off the graph, the point where x equals 0, which is the y-intercept. We're going to read the y value, and we're going to substitute those two values into y equals mx plus b. So let's have a look at this example. So what we're going to do in the first place is we're going to find 2 points, and we can draw 2 points on there. We're looking for where it intersects a point beautifully. So there's a point there where it intercepts a line magnificently, and there's one there. So we're going to pick off those 2 points because we can see they go through the intersect. We're going to do our triangle underneath. I'm going to put my rise over here. My rise is equal to 3. My run is equal to 4. My gradient, m, is equal to rise over run is equal to 3 on 4. I'm looking at it. It's positive going up, negative going down. My gradient is positive 3/4. Now the next thing I'm going to do is I'm going to have a look to see what the value of where x equals 0, what's the y value, the y-intercept, and that value is 2. So my formula, y equals mx plus b, m equals 3/4, b is equal to 2, y equals 3/4 x plus 2. We're finding that point at 0, 2, and our b value is the y value. Let's have a look at our next one. Now the other thing we can do is we can use the gradient at any point to find the equation of a line. What we do is we find the gradient, or we're given the gradient. We substitute the gradient for m into the formula, and then we substitute in the x and y coordinates of a point on the line, and we solve the equation to find the value of b. So in this first question here, it says the gradient m equals 4 is what this is telling us, and it passes through point equals 2 and 5. So if I write down my formula, y equals mx plus b, my m is 4. I have y equals 4x plus b. Now I substitute in my values that I've got. X equals 2, y equals 5. They've told us they're on that line, so it must be true. So 5 equals 4 times 2 plus b. That gives me 5 equals 8 plus b. And remembering what we need to do, we need to get b by itself. We want to subtract the 8. We subtract it from that side, so we subtract it from both sides. Minus 3 equals b. So my formula, y equals 4x plus b is minus 3. Finally, here's have a look at some special lines. Now, vertical lines. If there's a vertical line and we've got the rise over the run, the rise is infinite. We don't have a gradient. What we have to have is x. We simply have x is equal to the x value. So for this one here, all of the points are 2, and with the x value is 2, the y can change. So the formula of the line is simply x equals 2. Y can be any value. For our horizontal lines, we have the same scenario. What we have is we have the fact that the y is always the same value. So looking at this one, we can see that this horizontal line is going along at the value of y equals minus 3. Our equation is simply y equals minus 3. So what I'll get you guys to do is have a look at some of these, or have a look at these equations, do them in your book, and answer the questions on this Microsoft form.